Hello my friends, welcome back to this implementation. Are you ready to start that big for loop which will iterate through all the rounds, all the 10,000 rounds, meaning the 10,000 customers to which we're going to show the ad, and therefore in this loop at each step, well, we have to implement the 3 steps here. Well, we already implemented step 1, but we have to implement step 2 and step 3 at each iteration of the loop. All right, let's do this. Let's start this for loop, starting with for. Then we need to choose a variable name for, that iterative variable. And this time, instead of calling it I, as the classic name, we will call it N, because clearly what we are iterating through are the rounds, the rounds from round 1, the first user, to round 10,000, the last user, to whom we show the ad. Okay, so for N, in, and then of course, range from 0, because, indexes in Python start from 0, up to. And here you can either put 10,000, but we already put 10,000 in the variable, so let's put n, so that then if you want to try another number of rounds, you can just change the value of n here. Okay, so for n in range from 0 to n, then colon, and there we go, let's start that for loop. All right, so I'm going to scroll down a bit, from here, perfect, and there we go, let's do this. All right, so what do we need to start with? Well, right now what we want, what we ultimately want, within this particular iteration of number n, what we want is to select an ad, right? We want to select an ad, and we're going to select it according to these steps. We will select the ad that has the maximum UCB, upper confidence bound. So the first thing that we'll do is start from the first ad, ad number 1, but since we're going to work with indexes, the index of this ad will be 0. So I'm going to start from this ad equals 0. Here I'm introducing, of course, a new variable, add, which is initialized as 0, but then you're going to see that we will do a second for loop, which will loop over all the different adds one by one, starting from this one, add number 1 of index 0, then going to this one, add number 2 of index 1, and etc. up to add 10. Because indeed, in order to get the maximum upper confidence bound, we will need to compare the upper confidence bound of each of these adds. And therefore, we'll have to iterate through each of these adds to find the maximum upper confidence bound. And that's why right now, I'm initializing this new add variable as 0 to start with add number 1, and then we'll compute the UCB of this add number 1, and then through the for loop, we will get the other upper confidence bounds, and we will get the maximum one. You see the idea? Very simple. We just have to follow, a certain logic where we know that the ultimate goal is to select the ad that has the highest upper confidence bound. All right, so then, do you think we have to already start that second for loop? Well, almost, but we need to do something else. We need to introduce a new variable, which will be, that maximum of the upper confidence bound. Because for each of the add through that second for loop, we will compute the upper confidence bound. But in order to compare them to the maximum upper confidence bound, well, a smart thing to do would be to introduce a new variable here that will be that maximum upper confidence bound and which will be compared to each of the UCBs of the ads. And therefore here, I'm introducing a new variable which I'm going to call max, let's say upper bound, all right, and which I'm initializing to 0 because indeed at the beginning, well, let's say that the maximum, the highest upper confidence bound is 0. And then, of course, once we get an ad that has a higher upper confidence bound than 0, we will update this value of max upper bound to this new higher upper confidence bound. All right, so all logic here. Then, now we can start the for loop, the second for loop that will iterate through the different adds from 1 to 10. So there we go, we start the second for loop for then a new looping variable, iterative variable, which we're going to call this time, of course, well, either add, but add is already taken, that's already an existing variable. So let's just choose I for I in range from 0, because indexes in Python start at 0, up to either 10 here or, d, because we already introduced that d variable, which is equal to 10. And if you want to do that same UCB implementation on a different number of ads, imagine you have, 5 ads or even 50 ads, well, you simply have to change that d value here and nowhere else. All right, so that's the purpose of introducing these variables here. So for I in range from 0 to d, and there we go, we can start the second for loop. And it is now in the second for loop that we will really implement each of these steps. So now is the time you're going to press pause on the video to indeed implement that step 2 first. I would like you to implement from scratch. You can totally do this because you have everything here. I would like you to implement that step 2. You have also all the variables, so it should be all fine. And then don't implement step 3, because that will be done for next exercise. And besides, it is not that direct. We will have to use a certain trick in order to implement that step 3. All right, so please implement step 2 now. Please press pause on the video and implement step 2. But let me just give you 2 hints, because maybe you will encounter issues with something. In this part, as you can see, you'll have to compute the square root of that value here. And you have to know that in order to use the square root in Python, you have to import a certain library, which is simply called the math library, and from which you can use a lot of mathematical tools like the square root. So actually, let's do it right now so that it's done. We can either import it here or, since I prefer to keep the essential libraries here, let's just import it at the beginning of this implementation. All right, right here, so that it's done, so that you can be ready to use that square root function. And then I will let you, of course, look in the documentation online what is the exact function name. So math, there we go. And then the second hint I wanted to give you was the fact that you have to start the step 2 with an if condition, right? Because at the beginning, no add was selected, and therefore this, this quantity is equal to 0 for all the adds. And if this is equal to 0, this doesn't make sense. It will be equal to plus infinity. So you have to start with this if condition to make sure that the add we're dealing with in this second for loop was already selected, so that this is different than 0 and this exists. And so that then you can indeed compute the confidence interval. All right, so that was the last hint. And now your turn. Please press pause on the video and please implement this step 2. All right, perfect. So now let's implement the solution together of the step 2. All right, so as we said, we have to actually start here with an if condition that will check if the add we're dealing with right now, the add of index I, has already been selected. It's not the case at the beginning, but over the round, it will be the case. The add will already have been selected, but at the beginning, for the first round, we need to check that indeed the add has been selected. So in order to check this, well, that's very simple. We have these variables that gives for each of the adds how many times they have been selected so far, at round n, up to round n. And therefore, we're going to take this now, and then we will check that the index I, which is the index of the add we're dealing with right now, in this numbers of selections list, well, we're going to check that the element of index I in this numbers of selections list is indeed larger than 0. Because if it is larger than 0, then that means that the add was indeed already selected at least once, okay? And now if you want, but that's totally optional, you can put this condition in parentheses, right? And then you add just a colon, and now you're going to say to Python what should happen or what must happen if indeed that add I, which we're dealing with right now in the second for loop, was already selected. All right, so now is the time we can implement all this, because indeed this is different than 0. This is larger than 0. So very simply, let's just follow this step by step. First, let's create a new variable for this, which we're going to call average reward, because this corresponds to an average of the reward, because it is the accumulated reward here of this add I up to round n divided by the number of times it was selected. So that's nothing else than an average. And therefore, let's create a new variable here, which we're going to call average underscore reward. And it is simply going to be equal to, well, the accumulated reward of that specific add I up to round n, which is given exactly thanks to this variable here, of which we're going to have to take the index I, right? The add I, which we're dealing with right now. So I'm pasting that here, and I'm taking, of course, in pair of square brackets, the index I, because this, all this corresponds exactly to the accumulated reward of that specific add I up to round n, okay? So sum of rewards I, and then, of course, we need to divide that by the number of times that same add I was selected, and this is given, of course, by this again, right? The numbers of selections of index I, which corresponds to the number of times the add of index I was selected. And that gives you exactly the average reward, that gives you exactly that value here, okay? So very easy so far. Then, next step. The next step is to get the confidence interval. And more specifically, we're going to get that value. So right now, we're going to compute this value here. All right, so let's simply call it delta I, as a new variable, delta underscore I equals, and now there you go, that's where you needed to take that square root function from the math library. So first we have to call indeed that math library, and from which, well, we need to call this function that allows to compute the square root, and I'm sure you found very easily online that this function is called sqrt, and then parenthesis, right? This computes the square root of a value, and the value we have to put inside this function is of course exactly this, 3 divided by 2 multiplied by the logarithm of the round n divided by the number of times the add I was selected up to round n. Okay, so let's do this. First we start with this 3 divided by 2, then multiplied by, then there you go, you need to call the log function, which is another function of this math library. So actually this math library is used twice. I'm calling it now to indeed be able to call that log function. And now inside this log function, well, be careful. Maybe I should have given you another hint here, but be careful. We cannot input n here. Why is that? That's because actually n, in this range here, this first range, starts from 0. So the first value of n is 0, and that's because of the indexes in Python. And you have to know that the logarithm of 0 is actually minus infinity. Therefore, it would be very dangerous here to only put n, and in order to protect us from this, we're just going to start from 1. Okay? That's one way to do this. The other way is, of course, to make that first for loop going from 1 to n plus 1, so that we can go indeed from round 1 to n plus 1. But with Python, we always work with the same indexes starting from 0. So that's why we go with the first option here. All right, so all good so far. And then, of course, we have to divide that by, well, let's look at it again, the number of times the add I was selected up to round n. And that's, of course, exactly this value. So I'm copying this again and pasting that here. And there we go. Very quickly, we got our delta I. We got exactly this value. And now we have a final value to compute, which is, of course, well, that long-awaited upper confidence bound. That's exactly what we have to compute right now. And it is going to be simply the sum of that average reward plus that delta here. So let's here add a new line of code and then introduce a new variable, which we're going to call upper underscore bound. Not max upper bound, but upper bound, and which will simply be equal to the sum of the average reward, there we go, plus the delta I. And perfect. And now, thanks to this for loop, the second for loop iterating through all the adds from 0 to 9, but from add number 1 to add number 10, well, we have the upper bound. We have the upper bound of each of these adds, and the upper bound at, that specific round n we're dealing with right now inside this first for loop. All right, so basically we're done implementing this step 2. We implemented this step 2, and we even got that value here, the upper bound, but now step 3 is not implemented yet, because indeed step 3 consists of selecting the add that has the maximum upper confidence bound. So now we need to add one trick, which is kind of classic in Python, but indeed we need to add one trick to select the maximum upper confidence bound of these 10 adds. So going back to here, well, we will surely take a little break here, and actually I will directly ask you to try to implement that step 3, between this tutorial and the next one. Before you start the next tutorial, please try to implement step 3. It's not that direct, it's not that easy, but you have to use some kind of algorithmic logic, okay? But I'll give you, of course, some hints, unless you don't want the hints and therefore you can directly press pause or quit this video now. But I'm going to give you some hints if you want. The first hint is that right now you're done with this if condition. So you can go back here, inside this second for loop. And then you're going to have to start with, of course, an else, right? Which is the condition where, that add we're dealing with right now has not been selected yet. So what you'll have to do, and that's my last hint, will be to use a trick to select the adds that have not been selected yet. Why do you need to select these adds? Well, the answer is here. That's exactly because of this, this denominator which shouldn't be equal to 0. And since this is exactly the number of times the add I was selected, well, we need this to be different than 0 in order to compute this average reward, and therefore in order to compute then the confidence interval with the upper confidence bound. And that's why in the UCB algorithm, it's compulsory to make sure that during the first round, all the ads are selected. So actually, during the first 10 rounds, we have to use a trick so that we make sure to select all the ads. So that this way, well, all the NIN here, for all the different ads will be different than 0. Okay? So basically the exercise for next time, the next tutorial, is to indeed implement that step 3 to compute the maximum of the upper confidence bound, while at the same time implementing a trick to make sure that all the ads are selected in the 10 first rounds. So pretty challenging, but at least try as hard as you can, and I promise you that you will progress and improve your skills in machine learning.